So welcome back. A single phase supply is given to pure L, AC supply which is given to the pure inductor. The instantaneous value of the voltage is V is equal to V max sin omega t. And what is the current through the inductor? 1 by L into integration of V dt. So 1 by L into integration of V max sin omega t into dt. So V max minus cos omega t divided by omega. Why? Because integration of sin theta is equal to minus cos theta, or integration of sin a theta is minus cos a theta divided by a. So here we can write it Vm by omega L minus Vm by omega L cos of omega t. So Vm divided by XL, where XL is called the inductive reactance, that should be equal to omega L 2 pi FL. Here the omega is equal to 2 pi f. We can write it as a sine of 90 minus omega t. Sine 90 minus theta, that should be equal to cos theta. So take a minus sign is a inside, sine of omega t minus pi by 2 degrees. And the instantaneous value of the current I is equal to I max sine of omega t minus pi by 2. Here I max is equal to V max divided by XL. See, this is the instantaneous value of current equation. The instantaneous value of the voltage equation is Vm sin omega t. So V is equal to Vm sin omega t, and the current is equal to I max sine of omega t minus pi by 2, and the instantaneous power is, it is a product of voltage into current. Say at omega t equal to 0 degrees, V is equal to 0. Why? Because V max sin 0 is 0, and I is equal to I max sine of minus pi by 2, that should be equal to minus I max, and the power value is 0 into minus I maximum is 0. At omega t is equal to 90 degrees, V is equal to V max, I is equal to I max sine of 5 by 2 minus pi by 2, that should be equal to 0, and the power is equal to V max into 0 is 0. Okay, in between we will take one more value, that is omega t is equal to 45 degrees. V is equal to V max sine 45 is V max by root 2, and I is equal to I max sine of 5 by 4 minus pi by 2, that should be equal to minus I max by root 2, and the power value should be equal to, so 45 minus 90, sine of minus 45 is minus I max by root 2. The V max by root 2 into minus I max by root 2, that should be equal to minus V max I max by 2. Set omega t is equal to 135 degrees. V is equal to V max sine 135 degrees, and then V max divided by root 2, the sine of 90 plus 45 cos 45 V max by root 2, and I is equal to, substitute here, sine of 135 minus 90, so this is also positive, I max by root 2, and the instantaneous value of the power is V max by root 2 into I max by root 2, that is V max I max by 2. After that omega t is equal to 180 degrees. After that omega t is equal to 180 degrees, V is equal to 0, and I is equal to I max sine of is 180 minus 90, yes, I maximum, the average power is. At omega t is equal to 225 degrees, So V is equal to minus V max by root 2. And the current I is equal to I max sine of 225 minus 90, that is 135, is I max divided by root 2, and the instantaneous value of the power is minus V max I max by root 2 into root 2 is 2. At omega t is equal to 270 degrees, V is equal to minus V maximum, but I is equal to 0, and the instantaneous value of the power is 0. At omega t equal to 360 degrees, V is equal to 0, and the I value is minus I maximum, because 360 minus 90 is 270 I maximum, and the instantaneous value is 0. The instantaneous value of the power is equal to, it is a product of instantaneous value of the voltage and current. So V max sine omega t into I max sine of omega t minus pi by 2, and V max into I max sine omega t into cos omega t. So minus V max I max sine 2 omega t divided by 2. So minus V max I max by 2 into sine 2 omega t. So if you draw the waveforms of voltage and current and instantaneous power, the instantaneous power, so this is the voltage as a sinusoidal waveform. So why? Because V is equal to V max sine omega t, and I is equal to I max sine of omega t minus pi by 2. So the angle between the voltage and the inductive current is 90 degrees, and that too current is lagging. Inductive current is always lagging. 0, 90 degrees, 180, 270 and 360 degrees. In between I have a 45 degrees, 135 degrees, 215 degrees, and 180 plus 45, 90, 91, so 225, and 270 plus 315 degrees. Okay, and the current waveform will start after pi by 2. So this will be 0 at by taking all the values. See here, at omega t equal to 0, it will be minus I maximum. At omega t equal to 90, it will be 0. So this is a waveform of the current. Instantaneous value of the current waveform is like this. At 180 it will be maximum. At 180 it will be maximum. This is 180 degrees. At 270 it will be 0, and 360 it will be negative maximum. The waveform is like this. So again, if you want to check the values, at omega t equal to 90 it will be 0, 45 it will be minus I max by root 2, as 45 degrees it is minus I max by root 2. I am drawing the waveform with less magnitude. Why? Because you can assume that Vmax is greater than I maximum. So by product of these two will use the instantaneous power waveform. At 0 into negative maximum is 0, and here at 90 degrees you will see at 90 degrees the instantaneous power is 0. In between at 45 degrees it has a magnitude, that too negative magnitude, minus Vmax into I max by 2. So at 45 degrees this is a Vmax by root 2, and the current is minus I max by root 2. Then product of these two is Vmax into I max by root 2. At this position 0, and at 135 both are equal, then should draw the waveform is like this. And at 180 the magnitudes are 0. See, you should find out the 0 values. At 0 is 0, 90 is 0, 180 is 0, 270 is 0, and 360 is also 0. If one of the waveform is 0, the product of any value with multiplied with 0 is 0. So these are the 0 points. In between what will happen, you will see. So by seeing that values, here negative half cycle, yes, this is a negative half cycle as a power waveform. At 180 it will be 0. At 270 the magnitude will be here positive. The magnitude of the voltage waveform is negative. As positive into negative, it is a negative. By taking the values, you should draw the waveform. And here negative into negative, check that at 315 degrees. Yes, negative into negative will give the positive value. So when the voltage waveform completes one cycle and the power waveform completes 2 cycles, this power is called the instantaneous power. And average power is equal to 1 by pi integration of 0 to pi minus Vmax Imax by 2 sin 2 omega t d omega t minus Vmax Imax by 2 pi integration of sin is minus cos 2 omega t by 2 0 to pi. So Vmax Imax by 2 pi, so this is cos 2 pi, anyway it is 4 pi, yes, cos 2 pi minus cos 0, upper limit is pi and lower limit is 0. Cos 2 pi value is 1 and cos 0 is also 1, and this average power is 0. The average power through pure inductor is 0. And I draw these waveforms based on these values. Take these values and make a comparison table and take degrees on x-axis. So x-axis it is omega t. On y-axis you should draw the voltage, instantaneous voltage, and instantaneous value of current and instantaneous value of power. And positive into positive will be positive, and here it will be positive into negative is negative maximum, and here positive into positive is positive maximum. And at this position this will be positive, current waveform is positive and this one is negative. Otherwise you should take these values and just do it. See, at 135 you will check at only one value, 135 Vmax by root 2, Imax by root 2, the power is positive. Check this, what, 135 degrees, yes, both are positive and it will goes to positive portion. So we did all 5 concepts, and third one is instantaneous power, and the fourth is waveforms, and the fifth is average power. But the average power through pure capacitor or pure inductor is 0.